There is a place in this universe so empty that if you spent your entire life there, you would have no real sense of how vast the cosmos actually is. Not because the technology failed you, not because you were not paying attention. Simply because there would be almost nothing in any direction to observe, measure, or point a telescope toward. Scientists have known about this place for decades. They have mapped its boundaries, argued about its origin, and sent successive waves of instruments at it trying to find something they might have missed. And every time they look harder, the emptiness holds. It sits roughly 700 million light-years from Earth. It stretches approximately 330 million light-years across. It goes by the name the Boötes Void. And the reason it matters is not just that it is large and empty, but that its existence quietly challenges assumptions about how the universe was ever supposed to be structured. Astronomers have been trying to fully explain it since 1981. Until now, they have not finished yet. In 1981, Robert Kirshner, Augustus Oemler Jr., Paul Schechter, and Stephen Shectman were conducting a redshift survey near the constellation Boötes. The work was not designed to find anything unusual. It was methodical cataloging, the unglamorous backbone of observational astronomy. But when the data came back, there was a gap where there should not have been one. A region roughly 330 million light-years across had almost no galaxies in it at all. The team published and the scientific community pushed back. So other groups went in with their own instruments across the following years. 8 galaxies confirmed in 1987. 3 more in 1988. 15 more in 1989. By 1997, after nearly 2 decades of searching, the confirmed total inside a region expected to hold roughly 2,000 galaxies had reached just 60. Every team that tried to disprove the Boötes Void ended up confirming it. To understand what those numbers mean, it helps to know how galaxies are normally distributed. Across the universe, matter forms a vast cosmic web of filaments where galaxies cluster, while the spaces between them become voids, typically spanning 30 to 300 million light-years. The Boötes Void sits at the extreme end of that range, a roughly spherical region where the filaments that should have formed galaxies largely never developed. For scale, the distance between the Milky Way and Andromeda is about 2.5 million light-years. That distance could fit inside the Boötes Void more than 100 times. Astronomer Greg Aldering pointed out an extraordinary consequence. If the Milky Way had formed near the center of the Boötes Void, humanity likely would not have discovered other galaxies until the 1960s instead of the 1920s. For nearly half a century, our understanding of the universe could have been shaped by apparent isolation, not because the science was wrong, but because the available evidence would have pointed in that direction. What caused the void to reach such an enormous scale remains a question the leading explanation can address, but not fully answer. The most widely accepted model suggests it formed as smaller voids merged over billions of years, much like soap bubbles joining together. Those voids originated in the early universe, when tiny quantum fluctuations created slight differences in matter density. Gravity then pulled matter into denser regions while emptier regions lost more and more material, gradually shaping the cosmic web we see today. The Boötes Void represents this process at its most extreme, a region that continued emptying without nearby concentrations of matter to slow its growth. This explanation fits within the Lambda CDM model, although the Boötes Void lies near the edge of what the model comfortably predicts. Its exceptionally low matter density also makes it a valuable laboratory for studying dark energy and neutrinos, both of which are easier to detect when ordinary matter creates minimal interference. The same emptiness that makes the void unusual also makes it scientifically important. Voids account for roughly 80% of the observable universe by volume. The glowing filaments in deep field images are a thin web, stretched across a vast underlying emptiness. The Boötes Void is not an exception to how the universe works. It is an unusually clear look at what the universe mostly is. The researchers who found it were not looking for it. The ones who followed spent 2 decades confirming what the original team saw. The scientists working on it today are still filling in gaps that first discovery left open. It has been over 40 years and the case is still active.